Okay, welcome to our What's New in IP and IC 2018 webinar. I'm Ross Brackenridge. I'm one of the hosts today. I'm joined by the rest of the technical team here who will introduce themselves.
Yeah. Hi, this is Paul Spooner.
Hi, Katrina Penman.
Hi there, Ron Lowe.
Hello, Clinton Pavio.
Okay, so those are our presenters for today, and this is what we're going to be talking about. So this is the agenda. You'll notice we're talking about IC and IP together today. It's the first time we've done our webinar about two products together. The main reason for this is that we've actually had a joint release. So in October we had a release of IP and IC 2018 together. But also that the two products are coming closer together now. They're becoming more integrated, and we'll be seeing some examples of how you can use the same database between both products. So we're going to start with, Ron's going to tell us about LIMBR licensing, which is a new licensing system that applies to both IC and IP. We'll then go on to the two IP sections. Firstly, the improvements to everyday workflows. So these are improvements that we've made to the base license of IP. So everyone that uses IP will see the benefit of these changes. The next section for new features and modules, so that's more focused on the improvements we've made to existing advanced modules. Then Katrina will be telling us about the improvements to everyday workflows in IC and also the new features and toolkits in IC. If you have any questions throughout the webinar, please feel free to contact us in the usual manner using our IP support and IC support email addresses. If you title the webinar, the email webinar, it might just help get the question to the right person a bit quicker, and we'll get back to you as soon as we can. Okay, so let's get started.
With the release of IP and IC 2018, we've introduced a new LR licensing system, LIMBR. It supports IP and IC 2018 along with future LR software products. It's been completely rewritten from the ground up to improve flexibility, reliability and performance. As before, it supports both personal licenses and deployable network license servers. The increased flexibility allows for multiple instances of modules. For example, we can combine some modules with a full license along with temporary trial licenses for other modules. As before, modules can be borrowed and returned to allow a user to go off-site with their laptop and continue working. LIMBR allows for simpler centralized license management. One license server can serve multiple license types, for example, both IP and IC licenses. The license server management console can securely manage multiple license servers remotely. The management console also provides a range of reporting tools which show how many licenses are in use and who is using them. There is a server management and reporting API which allows clients to develop their own license server monitoring tools. The license server service is also cross-platform. It's both Windows and Linux compatible. And finally, the license server service can coexist with other license servers like Flex on the same server machine.
So one of the first things you might notice when you open up IP 2018 is a couple of new options here in the file menu for saving and restoring IP sessions. So what are sessions? Well, it's a bit like when you close down IP and you open up again. It remembers which wells you had loaded, which plots you had open. That was your session that it remembered. We've now added the ability to have multiple sessions. So this could be very useful for those of you who work in large databases that maybe are working on more than one project within the same database. So what you could do is have a group of wells loaded, some plots, could be multi-well, log plots or cross plots. You would then want to move to another project, so you could save where you are as a session. So it's like a snapshot of where you are. You could then go and work on another project with a different set of wells. You could create a session for that project as well. Then you could move seamlessly between the two projects without the hassle of having to close everything down and open everything up again. So that should make it much easier quicker to move between projects within the same database. Backup parameter sets can now be hidden in your IP config settings. So backup parameter sets are part of the multi-user access security options that it takes a backup of every user's version of the parameter set. It's very important that it does that, but it has started causing your browser to become a bit cluttered at times. So there's an option in your IP config to make that invisible by default. Don't worry if you do want to see the backup data sets on occasion. You don't have to just keep changing your config settings. You'll notice that wherever you're listing parameter sets in IP, there should be a button now that allows you to make the backup sets visible. Okay. There's also an improvement to the selection of your zone sets when you're starting a multi-well interpretation. You've selected your wells and then it asks you to choose a zone set. It's now much easier to see exactly which zone sets exist in all the wells that you have selected for your interpretation, and you can easily sort these by set name type or the number of wells found. Still in multi-well interpretation, multi-well correlation plots, we've added a button now that you can actually detach these plots from your main IP window like you could do with single well log plots. So if you're working between multiple screens, you can now use that button to click and detach this plot right out of the main IP window. There's a new zoom feature if you right click on a log plot. So the area zoom not only zooms into the top and bottom depth of where you've dragged, but will also zoom in to the tracks you've selected. So it zooms by depth and by track. And of course that can be unzoomed as well. There's also a new option called unhide all tracks in log plots. So if you right click, you could always hide tracks. For some reason there wasn't a button there to bring them all back. There is one now. You'll also notice a couple of new buttons on the bottom right hand corner of your IP window. These are tile and cascade buttons, so when your workspace gets a bit busy, you can choose to sort your windows either by cascading them or evenly spacing them around the workspace by using the tile button. Coordinate reference systems. Up until now, IP has already accepted coordinates in the WGS84 format. Now we have in your IP config settings there's a whole list of the various coordinate referencing system. You can load the ones you want to use, and then when you go to your well header and click geodatum, you should get the option of all these reference systems. Whichever one you select, your coordinates will be converted to that system. We've done a lot of work in the background of IP for this release in respect to performance when using very large files. It's not uncommon now for service companies to be supplying DLIS files that could be 35 to 50 gig in size. So we've done a lot of work in the background to improve the speed when you're loading, saving, plotting, listing, doing anything with large data sets. You should see a marked improvement in this release. Curve grouping is a new feature that's been introduced. Think of it as a way of adding another hierarchy level to your data browser by adding in a curve grouping name in the curve attributes within the curve header. Any curves that have the same grouping name will be grouped together on the data browser. Here we've got some production logging data that we've now neatly grouped into the various passes. It can also be used for large array files, multi-dimensional array files. In fact, our dlist loader now has an option to group any multi-dimensional arrays together so they can be held together neatly in the data browser. So that's curve grouping. We've made a lot of improvements to the Geolog ASCII loader, so any of you who have recently moved over from using Geolog or still have some old Geolog databases, you can now import those projects without too much trouble. We now take in not only the data but also the zone sets, and we've also developed these two new features as well, which can be used for Geolog importing but can also be used in everyday workflows as well. So that's the multi-well zone linking. So you could always link zones from the same well together. Now you can do that across multiple wells at once to really speed that up. And replacing zones with picks. Again, this can be done across multiple wells now, as long as the names correlate with each other between wells. You can do hundreds of wells all at the same time. Primary well identifier is a feature that allows IP users to change the way IP identifies wells. In your well header, you will already know that you can enter a well name, you can have an API name, or a unique well identifier. Up until now, IP would always display the wells with the well name, but if you go into your IP configuration now, you will see you've got this primary well identifier option, and you have the three options in that drop down. Once you've set it, wherever your wells are listed, that could be in the well browser or when selecting wells for multi-well interpretation, you will see them displayed with the option you have selected. IP 2018 also sees some new display options, so if you go to your view menu you will see some new options. There's a box and whisker plots, so these are very good for displaying statistics on your data. So you can select a group of curves and you can display statistics on a single well, for different zones, or multi-well. And there's various options there for changing which statistics are displayed on the screen. The other new option is star and spectral plots. So you can see here we can use star plots, select some curves, and you can see how the relationship between these curves changes across different zones or wells. Again, it's single well or multi-well. You can actually change it from a star plot to a spectral plot, which is the same data displayed in a different manner. They're quite closely linked to the box and whisker plots, so if you already have a parameter set from your box and whisker plots, you can take that parameter set into star and spectral plots to allow you to display these options as well. So that brings us to the end of this section of improvements that we've made to everyday workflows in IP. There's quite a lot there, some bigger features, some smaller, but we hope that at least some of them you will notice starting to make your life a bit easier once you start using IP 2018.
The NMR interpretation module includes a new T2 wet workflow, which effectively performs fluid substitution on the T2 distribution The reason for this is to remove the hydrocarbon signal from the T2 distribution and replace it with a water substitution. And the two reasons for this is that the presence of the hydrocarbon signal in there, on the one side, suppresses the T2 distribution. Certain amplitudes are lower, so you need to correct for that. And then also, as a non-wetting phase, assuming it's a water-wet rock, the hydrocarbon signal carries no information about the pore size. So attempting to then invert that to a PC curve, a pore size distribution curve, and hence a saturation height-derived curve just isn't valid without doing this substitution. The key to this is the adding back in of the water signal. It's knowing where to put the water signal back in. And the way we handle that is via a calibration. If you make up a cross plot of free fluid bound fluid ratio against T2 log mean on a log-log plot, you tend to see a straight line relationship. Now, this data can either be from core data or it can be from a water leg, either down dip in another well or a deeper section in the same well. And then if we do a regression, which is what the module does, we can take the slope and offset of that line and then use it in the well to apply the correction. And this calibration can be performed using data from multiple wells, like I say, and it can be used with a combination of log or core data. And just like the permeability module, it can be done by zone or by fascies if you have a fascies zone to bring in, fascies curve. So let's look at this in a well. This is a gas well where we're actually applying the light hydrocarbon correction, so we'll use that. And there's a water leg down dip in here, so I'm just going to be doing this entirely in this well. There's no new input curves required for this workflow, but you do switch on the T2 wet calculation in the option in the output. That means that you'll see a new tab for T2 wet, a new set of parameters. The first parameter in here is where we define whether we're going to be calculating the hydrocarbon and water volumes from the light hydrocarbon correction or from an external SXO. If you select SXO, then you'll just bring in an SXO curve into here. And the module comes with a new interpretation plot. There's a new T2 wet interpretation plot. And you'll see on here an interactive line, which is the hydrocarbon T2. You can make an estimate directly straight by making a pick off of the log. And then there's parameters in here to control the standard deviation, and we're using a Gaussian distribution of that T2 signal. If you want it to be a variable, you could either trace yourself a curve, or you could use the T2 log mean if you've calculated one as part of the module. You can calculate the T2 log mean of a bin over a specific part of the T2 distribution. So I've just done that here on the whole free fluid. And then if you use that in there, that means you'll be calculating a variable T2 now. If you notice, I've got a variable T2 here. The water signal being put back in, again, is controlled by a Gaussian distribution, and there's limits on it. But the key to it is the calibration, which is performed via a regression tool. And you can do this by zone or by fascies, and like I say, this is exactly like the permeability workflow. So I can put multiple wells in here, core data, log data, and then if you wish, you can perform a regression by fascies, or I'm just going to do all fascies here. And when you do a regression, if you pull up the cross plot, this is where then you can see just how linear. What you're looking for is a linear response in the data. And there's a little bit of filtering to take out the very tightest rocks, and that's the stuff down in here. Or maybe if you've got washout, so you've got spikes in the porosity, so a little bit of clipping. And if you see a nice, good linear trend, then that gain and offset can then be used. And it works just like the permeability. You can update the coefficients in the table, update the parameters, which means that automatically populates these into here. And then this is the final fluid substituted T2 wet, and it's showing you the T2 log mean, what we were trying to calibrate to, and then what we finally managed to calculate. And having performed that, the final step is to carry that through into the PC curve generation and SW height, and we also now output a pore size distribution. So on the PC calibration tab now, we'll be automatically using the T2 wet for doing the calibration. And also, again, we've got this multi-well as it is currently, and this can also now be applied by fascies, not just by zone. So that's another enhancement in the PC. And then in the parameters, once you've done that calibration, so the gain and offset come through now as curve, driven by fascies, if you want. And we've now included the contact angle and IFT, so that when you run the interpretation and make the plot, the final interpretation plot now includes a calibrated pore size distribution, along with the SW as a function of height. Saturation height has also had some enhancements, primarily the addition of a multi-well log plot. So now it provides using the multi-well correlation viewer, and it's automatically set that TVD is the reference depth, so everything's being plotted in TVD. There's also an option to define any particular well as being oil wet, which means SW will not be forced to 1 below the free water level. It will actually run your regression equation and calculate it as a function. So if you've made an appropriate function, then SW will not be forced to 1 below the free water level. So if we take a look at that in a project, so previously I've got 3 wells here, and you used to be able to pull up each individual well interactive plot and play with a IFT and the free water level, etc. Basically now that is all just included on a single multi-well plot. So I've got 3 wells in here, so there's my 3-well plot, and again each one is individually interactive, just like say 3D petrophysics. But because of the well group now, all 3 of my wells have been given the same group, so if I interactively adjust the free water level in one well, it adjusts it in all 3. If you've got different fault blocks, so for example if BlueCat 3 was in a different fault block, I would just change the well group number. And if that was then in a Griffin, and there might be other wells in group 2, so now if I adjust any well in group 1, it will be adjusted, and you can see now which wells are in which group. So now if I adjust the free water level in here, it only changes the group 1 wells, and group 2 wells are kept separate. So you can organize them by, if they're different fields across a basin, you might be working across a complete basin in here, or within one field and there's different fault blocks with different contacts. And this is where the option is for the oil wet flag, which would basically just calculate SW below the free water level. And the other upgrades are that we've added the user-defined equation to the separate equation for each PC curve workflow, so greatly enhancing the flexibility of that as well, because then that now means your user-defined equation, whatever equation that is, from a book, a JV or whatever, you can now make each one of those coefficients a function of another curve, so you can get really complicated now if you want. And finally, the interactive selection of a rock class number that was added in 4.4. That was currently available on the PC and height saturation cross plots, the apex plot and the pore size distribution plot. It's been added to the J function plot as well now. So you can derive your J functions and then set the classes if they don't quite fit.
There are several enhancements for the acoustic waveform processing module in IP 2018. These include the new presentation style of rose plots, designed specifically for curves and very often used for presenting fast angle, and helpfully make the identification of false anisotropies significantly easier. We've added our first iteration of reflection analysis. These include the traditional style of chevron plot, as well as a calculation of negative slowness. We're also generating the ancillary curve of integrated travel time on the fly. This updates as you edit DTC. We've also enabled the manual generation of fast and slow waves. This is a very often critical part of the anisotropy workflow, particularly after you've edited fast angle. We've also added a new semblance processing method called combine wave. This is an adaptation of the common transmitter stack, automatically correcting for move out, enhancing signal to noise ratio, particularly useful when one is processing for higher vertical resolution. We've added two waveform pre-processing tools, the first removing DC signals, the second removing common mode arrivals, typically things like SON signals or casing arrivals that are present in waveforms. We've updated the way that early and late parameters can be edited, allowing you further control over the semblance map, as well as addressing several bugs and client issues. This dataset, processed with our reflection ID tools, shows the traditional chevron patterns appearing in the Stoneleigh waveforms, both for the far receiver and for the near receiver. When we process those same Stoneleigh waveforms for negative slowness, we can also see a bright semblance peak here, indicating that there is indeed some kind of reflection source. Shown on the diagnostic window, we can see that late in the arrivals there certainly is some kind of negative pattern appearing, as indicated by the slope on the window. Certainly when we browse through the well, we can observe that those reflections arrive at different times. This gives us further indication and confirmation that there is indeed a reflection source. The anisotropy log plot shows several enhancements, including the curve rose plot, which updates on the fly as you edit fast angle, and then once editing is finished, contains the button for generating the fast and slow waves. Once generated, these waves will be presented on the log plot, shown with the time window that we use for calculating anisotropy. This is presented along with several other QC curves, such as the minimum, maximum energy, and fast and slow slownesses. The anisotropy diagnostic window has also been updated, critically for the time window that's used to calculate the anisotropy maps. This window is now an interactive parameter. You can edit it and on the fly see how your changes will affect the generated anisotropy maps, both for energy and for slowness. The semblance description window is a recent addition, showing exactly what we mean when we say common transmitter or common receiver. You can select any set of waveforms that you'd like to see, and you can also see how the changes that you make affect either signal to noise or how they affect vertical resolution.
Okay, I'm going to show you some of the new additions we've made to the production logging module, specifically for the PL array workflow, which already existed, but previously one of the limitations of that workflow was that we were still using the traditional method of calculating velocities from spinners as we did for the conventional tools. So the old module, it was quite time consuming to calculate a velocity from each spinner because you had to do each one individually. We have now solved that issue by allowing you to, this is the new module here, you can actually take in all the spinner data from all the passes, from all the well conditions, and ultimately you can very quickly calculate a velocity from every spinner curve, from every pass, from every well condition with one run of the module. So it's speeded things up significantly. It's also more accurate because it actually considers which fluid the spinner is sitting in at any one time. If you think, once we're dealing with array tools, you could have a situation like this where at the same depth different spinners are actually in different fluids. So it's very important to understand what fluid the spinner is in before you calibrate that spinner, and this module now allows us to do that by applying a different slope and threshold depending on the direction that the tool is moving and also the fluid it's in. So the module requires all these parameters to make the velocities. It will try and select these automatically. It may not calculate a value for every cell. If there is gaps, you can use the surrounding data to make an estimation of what you think the slope or threshold should be, so you can fill it in manually like that, or you can go back to the actual spinner cross plots and manually look through each of the spinners, use these filters here to try and work out what the optimum slope and threshold is for each spinner. If you find values that you're happy with, you can then copy these into the final values, which is ultimately the same values that appear in this table. So by really considering which fluid we're in and what direction we're going, we should be calculating much more accurate velocities now with that module. Another addition we have made is to the flow calc array module, where we're actually calculating the flow rates. We've actually added this segmented results tab, so this just helps you better visualize the results. So what we have here is production rates, water hold up and fluid velocity from each zone displayed as a histogram or a borehole cross section. And you can see how the results change drastically from the top of the borehole to the bottom. If you're just looking at a table that shows you, or a log plot that's showing you the total of these values or the average of these values, you're not really getting an understanding of what's going on downhole. You can do that with this, and you can see, for example, here we are getting mostly upflow throughout the borehole, but at the bottom we're actually seeing some downflow here as well. So that's something that you just wouldn't be able to understand properly without visually seeing the results like this. Okay, so that is the additions we have made to the production logging module for IP 2018.
In IP 2018, we've added several enhancements to the image analysis module. Firstly, we've added several new tool templates. We've also enhanced the handling of the gain curves for the Baker image tools, and also AutoDip can now be run on the Image 360 tools. We've added new options for image filtering. These apply transforms to the actual data and write out filtered curves. This complements the existing image enhancements, which are display only and are not written out as curves. The image filter module comes with 20 predefined transforms, and the user can add custom transforms by editing the definition file. A new image tool is created for each filter which is run, and these pick up the new enhanced curves. There's also a new image deconvolution filter, where we deconvolve the image into a low frequency background image and a high frequency foreground image. The low frequency image responds to the underlying lithology or fascies and can be used as input to the rock typing modules. The high frequency image, on the other hand, has had the low frequency information subtracted out, leaving a clearer image of bedding, fractures and other artifacts that can be used, for example, to pick fractures. The new options are to be found under the Apply Corrections menu, where we have two new options here, Image Deconvolution and Image Filter. This brings up a pair of new tabs which allow the user to configure various options relating to how the averaging is performed for deconvolution, and on the Image Filter tab we have the 20 predefined filters here. Once the filters have been run, we will end up with new sets here containing the processed pad data. In addition, you'll find that new image tools have been written out, and now we're able to launch plots using these new tools. We can then pick on these in the normal manner. And finally, we've upgraded the NavQC tool, which was previously implemented as a user app. It's now a full IP module. It supports the Schlumberger, Halliburton, Baker and Weatherford tools. The workflow has been streamlined. After you select the input tool, it's a simple matter of launching the log plot and cross plot. The user can then zoom in to an area of constant deviation, for example, and inspect the cross plot for any evidence that the accelerometer or magnetometer data may have offsets on it. And if necessary, it can be recentered, either automatically or manually, and the inclinometry curves can be recomputed. On the log plot, the previous and recomputed inclinometry curves are plotted together for comparison. We also have the ability to bring in an external directional survey in the case that the magnetometer data is affected by environmental conditions in the borehole.
Okay, just before we finish up with IP and move on to IC, just another couple of things I wanted to mention. So within our unconventional resources suite of modules in IP, there's a rock mechanics module. We've added a new output to that, and it's a brittleness index that can be used for selecting fracture depths. It's based on this SPE paper here. We've always outputted a horizontal vertical stress ratio within this module, but some of you wanted us to add in this method as well, so we have added that. Briggs color cubing is actually a user app that we've created. It's not part of the install, but if you're interested in having it, just contact our support desk and they'll be able to supply you with it. So it's based on a paper that was presented at the SPWLA this year, and it's a method for normalizing your potassium, thorium and uranium curves, and then using them to color code your gamma ray shading. So it's quite a neat module, and it also shows how quickly we can react by using our user app functionality. This only happened earlier this year at SPWLA, and so we can very quickly create a module that applies that technique using our user apps. In the next section, Katrina will be talking about how the integration between the IC and IP products has improved. So I just wanted to show you this database within IP. In here we have a database with 12 wells. I have made use of the primary well identifier, the new option, so you can see it's using API numbers here to identify the wells. I have also made use of the new geodatum options. So here I've actually switched over all the wells to ED50. So Katrina will be importing this database into IC, and you'll see how these things will be persisted in doing so. Okay, so that really brings us to the end of section 4. So that's us completed the IP sections for today. So over the next 20 minutes or so, Katrina Penman is going to be telling us about improvements to everyday workflows in IC, and also the new features and toolkits within IC. Just a reminder, any questions you have on anything you see in the webinar today, please contact us using the email addresses here. And if you could title the email webinar, it might just speed things up. Okay, so over to Katrina.
Hello everyone, I'm going to spend the next few minutes talking about the improved IP-IC synchronization that was added to IC 2018. As you can see from the list here, we've added geosteering and geomechanics parameter sets to those that can be shared, as well as bringing over new well attributes and being true to the primary well identifier chosen within IP. This IP database has 12 wells, and under the Tools options we can choose for this dataset what primary well identifier to choose. When I choose API, at my project browser on the left here shows my API numbers along with my well names. When I open up IC, we see that the list of wells shown are true to the primary well identifier and the well names as chosen. These can be manually unticked as always. As we step through, you're going to notice something slightly different. We have all those curve sets that we can share. The discrete data again can be shared. We have that geomechanics, geosteering cutoffs, and we have the project defaults for IC. Now this is new because IP is now coordinate aware. When we talk about IC, we set a project level coordinate reference system. So any of those geographic or grid systems that you chose within IP, as Ross showed you earlier, we now get to choose those for IC. So as there's no grid systems in here, I get to go in and manage my coordinate systems directly and choose which ED50 UTM zone I want to use, and I know it's 30 north. So now that will be there, and this is now me ready to build my IC database. We're sharing that data, and the visuals will open up and we can start mapping. You can see from the project browser in IC, we are true to that PWI. It comes across and is displayed alongside our well names. If we open up one of these wells, you can see that the API is being shared, and that is what's being displayed up here. All the other attributes can be shared, including that coordinate reference system. If we expand some of these wells, we will see the IP parameter sets. So we've got the reservoir and pay cutoff reports, our picks, our tops. So we can open up any of these and display the values within the tables. And the rest is as it was. A lot of the continued improvements to our everyday workflows have been focused on our charts and our mapping interfaces, that very visual interaction you have within IC 2018. We've added in new displays for our category plots, looked at how we can improve how our log curves are displayed, improved the way that point data can be displayed, and how when editing data you can improve that no snap option. When it comes to the maps and the workspace itself, we have a lot more information now displayed in that kickboard. We have tooltips available now when you have lots and lots of windows minimized, so you don't have to expand them all to see which you want to work on. We've done some work that will allow you to manually alter your surface grids, as well as providing the means to show all of your data for a particular well in what we call a dynamic template. The last thing that we've added into IC 2018 are improvements to the charts with regard to adding in standard shape. We've also added in our clip art library, so this is a nice way to store external graphics. Within IC, one of the first things I'll show you on the charts is the new drawing capabilities. So these shapes up in the drawing section of the chart ribbon that allow you to add in new shapes very quickly. The style of the shapes themselves can be modified by selecting them and changing the outline, colour, shape, thickness, or the fill itself. And you can see that we have the ability to order these like any other object on the chart. We can add text to these and orientate them as we see fit. We also have the ability to manually move these. So you can see here straight lines are very easy to help pick out a correlation tie. We also have that clip art library I spoke to you about that you can drag and drop onto your chart and then change the size manually. These can be removed very easily, and this can hold as many images as you like. The visualization of the data on the charts has changed in that we now have the ability to maintain the well header and scroll up or down to move the depth range displayed within your charts. Now you're seeing the ties disappearing and coming back in as the depth ranges cut them off. We also have the ability to choose a particular zone and zoom in, changing the scale. based on your mouse location. This can be done with multiple wells or single well. This same toolset can also be used on a cross plot. So if you have a scatter plot, for example, and decide that a certain area looks interesting and we want to see further changing those X and Y axes scales interactively, the same happens on a map when the AOI can be zoomed in or out, depending on what you wish to look at. We have the ability now to visualize a single curve in multiple ways based on an interval value. So for example, here I have a gamma ray that's raw. This is what's stored at the data level. We have the standard deviation plotted. Over here we've got linear trends, we have average values based on the intervals, and I've used my top zones over here. And I also have the ability to plot my P10, 50 and 90 to see the variations within each zone. This doesn't create new logs, this doesn't store new data in the database, this is purely for visualization. The kickboard down at the bottom will now show you not only the data type being displayed, but the name of the zone that you are moving your mouse over at the time. You can now edit surfaces. So under the right click you now have the edit option, which you can now decide to add a pseudo well or just a control point that you want to add. If I choose this value and add it over here, you'll see the grid has been rebuilt based on a new control point being added as a result of the value I picked up from over in this yellow section. And I can keep adding that same value. These points can all be removed very easily to go back to your well-controlled display. The last thing I want to show you are the dynamic templates, which will give you that visual QC of your data. You have these dynamic templates now. You choose the depth you want to look at, and what this does is searches through the entire database and generates a data panel for each populated data type stored in your manager, including any IP sets that might be shared, and your curve manager, organised from the top down from left to right. So you can see I have a lot of data stored for this well. This will be all my IP parameter sets inputs. So all these displays, if a dictionary is present, then the dictionary colours are used. If there is no dictionary present, the default display styles are used. So you can see as we get through all the discrete data, we start looking at the curve data. These templates can be modified like any other well stick on a chart at this point. Anything that can be controlled within this well header properties can be altered and saved as a new dynamic template. So we've looked at some of those display options for our well sticks, our zooming and scrolling options that were added in, our new category plot styles, our editing of a surface via manual adding of control points. We've looked at that kick plate where we see that extra information, and we've had a look at those dynamic templates, and we have those new shapes and the clip art library, all in IC 2018. I'm going to take the next few minutes to show you the improvements to IC 2018 with regard to the database management. We have improved several things with regard to the user control and security, adding new privileges for dictionary lockdown and setting in default interpretations, being able to display interpretations. We've also improved our well query dialog, added in extra options to truly search the entire database. We've improved our data links with regard to OpenWorks, and our Portrayal plugin now has overwrite capabilities. We've improved our Spotfire export options with regard to choosing a depth range, be those manually entered or set to a data type. We've also improved our PDF printing of any charts or maps, going up to 600 dpi now. Other options are locking down charts, so no more accidental deletion or overwriting of work already done. And we also have some new highlights in the data browser, and dynamic projects is a brand new item for you. So we'll shift over to IC and we will have a look at some of those items. When it comes to administrator control over the users, we can have each user profile set to this new maintain dictionaries item, which will lock down or open up all dictionaries within the database. We also have the ability to set a default interpretation. So when you have lots of data, lots of users, lots of interpretations, some people are using individual named interpretations for their working dataset. And this allows you, when looking at data from tables, to open directly to your default interpretation rather than the none. When it comes to visualizing and seeing this kind of information, we have a new option underneath the well header properties. That's this simple tick box, show interpretations, which you can see is applied when you have multiple entries, multiple data panels looking at the same data within different interpretations. So without it, all you have is the same data type, but when you add in that interpretations, you get the named interpretation 1, named interpretation 2 to highlight those differences. It's still the same access to browse the data. It's opening up the data type we were looking at. And while we're in here, we'll have a quick look at some of those QC visuals. For example, when you have data that has 0 thickness, you are highlighted. You're allowed to have 0 thickness units in a data type, but it's highlighted for you in case you didn't mean to. We also have the ability here to highlight any zones that have depth busts. So as you can see, the base here is lower than the top of this zone here. We also have the ability to highlight where boundaries mismatch. So we have the same depth but the different boundaries. So you can see those 3 different colours there to highlight, draw your eye in and alert you to what you should be looking for. As you can see on the left here, I have an example few charts under some folders, and I have an example chart here that has a little padlock icon to highlight to me that that is locked, which means if I make any changes to this chart itself and go to save, it will not overwrite that locked chart. If you want to save things, you can give it a new name so it turns into the save as. All you need to do to lock a chart is tick this little box down at the bottom. Anyone can lock or unlock any chart. This is just to avoid those accidental overwrites and loss of data. The query side of things still accessed in the same way, but the visualization is slightly different now. The well headers, all those attributes are still there. The well name and well path options, RPM tables, any shapes stored within the GIS or the IC polygons resources can be used as a geographical reference to query things. We also have the ability now to search which wells are found within certain charts or on certain maps. The subqueries allow you to really easily select very simple queries and add them, build them all together. And once you have a query in place, you can save these now directly from the right-click option as a text file or an IP-specific well list. One of the powers behind the queries now is the new dynamic project. What we now have is an option to set a dynamic project based on a query at the highest level that allows you to choose which wells should be included in your project. So we've gone through a lot of the visual impacts. I haven't gone into detail with regard to the imports and exports. That's self-explanatory when you're in those dialogues. We've looked at locked charts, locked dictionaries, setting those default interpretations and being able to visualize very easily on your well sticks what data you're looking at. And we've also had a quick look at the well query layout now and how that can be applied to generate dynamic projects. One of the new toolkits added to IC 2018 are the ternary plots. So going beyond that cross-plot 2 axes, we now have the 3 axes QFL style plot that can be added to any chart. We've added in similar filtering options that you're used to with cross-plots. We have added the ability to add overlays and then post data back to the database from these ternary plots. From within IC, ternary plots are an object on a chart that can be used as part of a montage or as a single display. Once open, the Properties toolbox allows you to choose the wells to include, which data to focus on, what filters to use, add any overlays, and build a report. This is a very simple ternary plot. We have a handful of wells. We're looking at our sand, silt and clay composition from our analysis results, and we have set the default plot styles to be a specific shape, size and colour. When we use filters, we change one of those attributes. If we add in our tops and set those to be colour, the dictionary is used to pick up which colours to show. Once any change is applied from the toolbox, the ternary plot is updated. Beyond here, we have options with regard to how these filters are displayed. When it comes to overlays, we have the ability to import directly from a file. These are the same overlays that IP can also use, so if you've generated them in IP, you can import them to IC and vice versa. I already have one on here. If I apply that, you will see my colours. I can modify these very easily. My clay changed up here. I can also create a new overlay, provide it with a name, and start drawing areas. These are completely separate to the overlays we already see, but allows you to manually cluster specific areas. Double click will end the drawing of the polygon and you can provide a name. You can also change the colours and apply those. There are options when it comes to the ternary plot overlays, whether you wish to show them with labels or without. And if I tick off this show labels, all the names disappear. However, you can add them to your key panel. When we produce a report, it picks up all of the details of the inputs, the wells, the data points that have been used, and plots them as a table. At the end here, you see the overlays where each of these points sit. From here, we are able to push these back to the database, and from then we can actually use those when it comes to plotting well sticks or building queries. Which wells with a specific zone have clay, silt, shepherd sedimentary classification. All you need to do is choose which of these columns from the report table are to be saved in the database. They all have the depth associated, and you just need to pick the data table. So if we go to ternary report, and right now we have a generic overlay 1. And then you get to choose which interpretation to save it under. So the calculations that are done with regard to the data coming in and the normalization, that's all done in the background and the results shown here. So if you wish to use those, you can save those back to the database as well. So now if we go back to our data browser, we now have the ternary report data table that I saved under the none with my overlay entries. So that was a quick guide through how to access the properties of a ternary plot, how to modify and generate your own overlays, and how to display and add filters to the data used. I'm going to take a couple of minutes to show you our new feedback form within IC that came out for 2018. This is a way for you to directly get in touch with the support team without having to go and separately open up an Outlook email window. Regardless of where you are in IC, be it a chart, be it a map, be it within a data browser, up in the top right hand corner we have the feedback form. It allows you to send back some positive feedback, give us some negative feedback, report a bug, or ask a question. So you can choose any of these, give us a subject, and it will automatically pick up the name of the person that's logged in. So as I am using an Active Directory, it's picked up my name. I can say which country I'm in, and here I get to type in more information. I also have the ability to take a screenshot. So by ticking this box, whatever my IC window is showing at the time, that may be an error message, it may be a specific data browser, a specific chart. That will help when it comes to telling the support team what's going on, what you need help with. On top of that, you can attach files, so if you're trying to import data and you've got a LAS file that's causing problems, you can add that as an attached file, and then you get to send. And that will go directly to the support desk, icsupport@lr.org, and it will be flagged up for the team to get back to you. So it is a very simple dialogue that allows you to flag a particular issue and helps you take a very clean screenshot of what you're working on in IC at the time.
Okay, thanks for that, Katrina. So all that's left to say is thank you from myself and the rest of the technical team here. We hope you've enjoyed today's webinar. Remember, any questions, please get in touch. You can see the email addresses there. So please feel free to get in touch with us about any questions you have. So thanks again, and hopefully we'll see you next time.